Yeah, thanks to come to my talk, what's going on in my cluster. I hope you all had a great night out last night. A personal apology to Lian, sorry, I'm not sure if she's in the room. I didn't make it to the karaoke last night. I have 2 talks today, and I was afraid this might end up in a disaster. So, but I hope all the rest of you had a good night out. Now, that's where we started. So this is me. A few words about myself. As just announced, I work for this company called Novatec. We are a first-time proud sponsor of this conference. Not the first-time sponsor, but the first-time sponsor of an on-site conference. And that means we have a booth, so you're all welcome to visit us at our booth. What I do in my daily job is basically I try to learn and understand the various cloud-native technologies. And once I think I understood a little bit of them, then I try to pass it on to other people, like our clients, our employees, and also to students. I'm teaching distributed systems at 2 universities at around Stuttgart. And if you want to get in contact with me, there's like LinkedIn and Twitter are probably the networks I'm most active in. Now, to focus a little bit more on the topic. So what's going on in my cluster? Why would I give a talk about that? Why would people be interested in? This is the talk kind of in a nutshell. I will try to show various options and possibilities to help understanding what's going in and around the cluster and like getting people to understand, is the utilization okay, is the health okay, and whatever I need to know about my cluster. Yeah, so of course this is about the topic of Kubernetes. And this is also an intro and overview flagged talk. So please don't expect super advanced customizations of Grafana dashboards or extraordinary Prometheus queries. This is more like to get an holistic view of what are the options to monitor and observe Kubernetes. And also, yeah, what do I really want to see, and what is the price I'm willing to pay for that? Now, as this is introductory, I will first of all go a bit into the topic of a cluster. In a very, I guess most people of you have heard about the topic of Kubernetes and are fairly familiar with what it does. So in a nutshell, it is a distributed system, which is already complex enough. And to make things even worse, people try to run distributed applications on that. So if you want to understand what's going on there, you should probably understand the overall system. So it's a better kind of a mix of application workloads and infrastructure. Now, look a little closer at the infrastructure. The nodes can be separated into like worker nodes and the control plane, which is sometimes also referred to as the master node. And they have various functionalities. So the worker nodes would actually run the application workloads. They can kind of be considered as like a distributed container daemon. And then there is the control plane or master node, which hosts all the API objects in a database. So both of them have to be healthy for a cluster to really work fine. The control plane is also important for us in this context because it runs the API server. And the API server is one access point to query information about the health of the nodes and the application running on the cluster. So something we're going to look into. Yeah, so if this is not enough, people might also be interested in about how are my workloads actually connected? Who is talking to whom? Are those connections okay? Are they fast enough? Do I get the performance that I need? So all of this together is kind of what I consider as observability in and around Kubernetes. Now, let's focus a little bit more on the application side of things. As you probably know, you cannot run applications directly in Kubernetes. They have to be running in a container. So this is not the only layer. Kubernetes wraps it into another layer, which is called the pod, which is technically speaking an API object and not a workload, but I just draw it that way. And these pods will be running on one of these worker nodes. So you have various levels of complexity and various levels of access. Now, if you want to observe that, you can kind of plug into many different points. As I said before, you can reach out to the API server. You can basically try to get information there. You can also use and install agents or proxies to basically install something within the server that gives you more information about the running components. And you can do this on various levels. So you can install things on the nodes. You can install things like in the application or in the application container. Or you can also access the pods and put some kind of networking proxy or agent in there to query information about the network connection. So these are the various things I will try to look into a little bit. So I'm not trying to focus super much on a certain distinct technology, but more like what can you expect as metrics to get, and what is basically the overhead that you will get once you do so. And then you can decide for yourself what is really important to us. What do we want to do? Is it like more that we want a high-level metrics, or do we want to like isolate things, isolate problems, or do we do deep dive monitoring of our applications? Now, of course, there are tools to do so. You are probably familiar with this website. This is the CNCF landscape, and I normally refresh that screenshot every time I do a presentation. This time it's the first time that I didn't get the entire landscape into a screenshot. So there are plenty of tools. This is kind of the good and the bad thing around Kubernetes. You have a lot of options, but you have a lot of options. So you need to decide which one do you want to pick and which one is the right for you. And most likely, like myself, you're in a constant evaluation of those things. Now, if you drill down, there is one chapter about observability and analysis, and there are some tools on that page we're going to see today. Of course, not all of them. I only have 30 minutes, which is a bit of a problem. But in the end, you should be able after that to decide yourself and say, well, this is one I should probably take a closer look into. Now, the first thing we're going to look at is the access to the Kubernetes API. So this is basically the entry level of observability, and you can already do quite a few things with that. So going back to that initial diagram, this is basically the access path where you reach out to the API server. You can do that either directly using the Kubernetes CLI and executing queries like kubectl, get me some objects, describe them, give me the details about it, do logging. There is a new call with recent versions. You can do kubectl debug, where you can basically run a shell in a container that doesn't have a shell. Or if it has a shell, you can use kubectl exec to execute a shell in a container and check things right there. Now, you can also use tools to do that. If you don't want to, I mean, of course, the scope of a command line is kind of limited to the dimension of your screen. There are tools around there where you can either observe things on a web browser or on a fat client or a command line interface. So the ones that I basically try to highlight here is K9S is one that I use fairly frequent. Even if you don't have a proper GUI, so to say, you can still improve your command line experience by using that. There is Octant as a web-based solution and Lens as a fat client. I'm sure they're not the only ones, but they kind of give you an idea of what you can do there. As I only have half an hour, I will try to put the demo parts towards the end of the presentation. I'm not sure if I ever even get there. So if I don't, you can always come over, of course, to our booth, and I'm happy to show you things there. So this is K9S and on a screenshot where you get like a quick overview of what is actually the health state of your pods, of your other API objects, even the nodes and so on. So it won't give you all the information about the health of your application, but it's a quick identifier to see if actually something is really wrong, you would probably spot it there easily. However, you could, of course, have running ghost containers that actually the process is running, but your application is not healthy. They will be more difficult to spot there. This is a screenshot from Octant, and this is one from Lens, so I don't really want to go too much into detail there. But those tools are also particularly helpful if you are getting started with Kubernetes. I mean, I'm teaching classes on Kubernetes quite a bit, and in the beginning, it's hard for the people to understand what are the various API objects, what are they being used for, and how can they basically kind of group together. So you will get kind of a grouping in those tools, and so you can basically use this as kind of a Kubernetes browser, so to say. All right, so to sum things up on the Kubernetes API kind of things, the definite advantage in there is you don't need to change anything in the cluster or the apps to run it, because you run the things on the outside and you just like query information. So it's completely non-intrusive. It's very helpful to understand Kubernetes and getting a quick overview, but there are limitations. So what you don't get to see there is any kind of network information. So you get the monitoring on your individual components, but you would not be able to see who is talking to whom, how is the performance between those components, and also, as I said, if you have like an application which is kind of broken, but the process is still running, you would have to go into the logs and find out there. You don't really get it on an overview. But as I said before, to detect things quickly and get a quick health check of what is going on, this is definitely okay. Now, I'm gonna get a quick sip to drink. The next level of observability I want to talk about is on a level of pods. And the most obvious solution in there is the technology that you might have heard of is called service mesh. Service mesh might not be the first thing that comes to your mind when you talk about, when it goes in the direction of observability, because a service mesh can do a lot more than that. But so the way it works is like the diagram that I showed before. You inject an agent on the pod level of your application. And I will go into a bit more detail how that works. Now, as I said before, observability might not be the thing that you think immediately when it comes up to service meshes, but there was a recent survey from the creators of the Cilium technology that I will show later on, to ask what are the features or what are the functionality from a service mesh that you would be most interested in. And surprisingly, it was observability as kind of the #1 thing, where I would have imagined more like on a traffic shaping or a security thing. But anyway, so people do use service meshes to get insights on the application flows within their clusters. So how that works, I'm going to go through this quickly. So we know the applications are running in containers, the containers are running in a pod, and a pod can basically host more than one container. So they're going to connect it to a network, and you can put multiple containers into such a pod. This might not always make sense if it's two application components, but the functionality you're going to get there is those containers will basically share the same network. So you don't need to do any additional communication. They can contact each other on localhost. That means the network traffic that goes into one of the containers, the other one will see as well. They also share the same file system as they run on the same node, but that's not so important for the observability part. So the really important thing is they run on the same network. And now if I use the additional container not like as an application container, but like as a proxy or monitoring agent, that means this proxy will all see all the inbound and outbound traffic of my application. This starts to make a lot more sense if you inject those proxy components into each of your applications. Because then the aggregated information from all of those proxies can be evaluated, and then you will see, who is actually talking to whom, how fast does that work. And the place where all this information is being gathered and evaluated is called the control plane. The monitoring side of things is being called the data plane. An advantage of that is that it doesn't really interact with the application that it monitors. Actually, the application itself doesn't even know or feel that something like that is happening, because it's only injected on a network level. So that also means if you have a polyglot microservice environment and have your microservice written in different languages, it will always work, because it does not interact with the application, only with the network. That is, of course, also a bit of a disadvantage, because you will not get application-level metrics by using this solution. Another advantage is, as you don't have to change your application or your application container, you can easily just like add them Sorry, this is going too fast. Yeah, you can just add and remove them without the application being affected. So then you can get information like this. You see the traffic flows. Also, if you have very different versions of applications, you can basically see how is my traffic distribution, how is my response time and all that. So this also helps a lot to see or visualize how is actually my application behaving. Of course, you probably would not need a service mesh if you have an application that only consists of 3 components. People do that, but I don't recommend it. But once it gets more complex, of course, this can be quite a help. So this is the Spring Pet Clinic example that I used to install it with. And of course, once it gets bigger, you have more insights of actually where is my traffic flowing. This solution that we're seeing here is the Kiali console. This sits on top of the Istio service mesh, but this is just a sample of basically what you might be able to get off this technology. Now, this technology comes with a price. Not like a price in money, but a price in overhead. So basically, the technologies are for free. But as you have seen, on the one side, you will have to inject these proxy components into each of your pods. Even if you scale them up, they have to be in each one of them. So there will be an additional overhead in terms of CPU and memory. But the more significant overhead is definitely on the network side of things, because just by the nature of things, you're going to add one additional network hop to it. So it has to traverse that proxy in order to get to the application. I don't want to go into the details of like how does Linkerd and Istio relate to the baseline. And they will always be different depending on the application, but it's just a natural thing that it is there. So this is one thing you need to consider if you go into that direction. All right, so the characteristics of this service mesh is like, yeah, injecting the sidecar proxy into each pod and get like insight over the network flow. You don't get application level metrics, but configuration changes at runtime basically means it's not at build time. So it doesn't need to modify the application component to get into that. Now, the next solution I want to talk about is like node-based monitoring. And the technology which is becoming very popular recently is called eBPF, which stands for Extended Berkeley Packet Filter. Now, if you read that, you probably might not think of observability in the first place. And I'm not sure if I can explain it all correctly how it works, but I can try to give you an idea of that. So technically, with this one, you place the agent not on a pod level, but you place it on a node level. The way eBPF works, this is coming from a very low-level Linux world, is that it runs kind of a sandbox code in the Linux kernel space. And with that, it's able to react and listen on kernel events, but it cannot harm the kernel. So we have Liz Rice here. She's going to give a talk after me. If you have any questions there, please ask her. Don't ask me. She will be better in explaining this. But one sentence that I learned from her a while ago is, you can imagine this like JavaScript in an HTML web page. So it can run and do the things there, but it cannot break out of that. That's the same concept there. Now, network events are those kernel events. So that means with this eBPF component, you are able to listen on that network level right on the kernel space, and then use that information and process it later in the user space. Now, looking at our Kubernetes nodes, we know it runs the containers, it has a container daemon, and of course an underlying operating system. This very often happens to be a Linux operating system. So that means it will work for this use case as well. Technically, or like the way it's kind of implemented is actually that you run your proxies or it's called eBPF edge components in this diagram, not close to the pods, but right on the network nodes. So you can also roll it out with like a Kubernetes deployment. They need to have, of course, some certain privileges to run there, but then they will query all the network traffic information on the level on the nodes and not on the level of the pods. Of course, in most cases, people will have a lot more pods than nodes. So this is a definite advantage to use this technology over traditional service meshes, because you only pay the price of running that proxy and having that overhead on the level of the nodes and not on the level of the pods. So this is a screenshot from the Hubble UI of the Cilium project or product, which monitors the same thing as I showed before. And as I mean, it's kind of really easy because you don't have to edit at a later point in time. You can install it on each of the nodes, and once you roll out your applications, you get the visibility and the insights straight away. All right, to repeat that real quick, you install that proxy component on the node instead of the pod. You use that Linux low-level functionality for interacting with the Kubernetes network traffic. This is, I think, still in the early stage of development. I mean, I only learned about it last year. There are a couple of technologies around, but I think this might have quite an impact in the future of how network is being done within Kubernetes. All right, so have a few minutes left. So finally, we can talk about the deepest form of like, let's say, observability, which is on the level of the application. So we've covered API server, nodes, and pods, and now looking at the application. So this is kind of tricky and more difficult to explain because, of course, each application is kind of different. And in that case, the monitoring agent needs to be aware of the application programming language or the framework that it's basically being used to work with. So the way it works, of course, the metrics also need to be instructed by the agent. They got to be aggregated somewhere and then displayed to the end user on the screen there. So this is a screenshot from the Jaeger UI. And in this case, you can see your level of observability doesn't end at the network level. It goes right into the application. So you can really see, this is a Java example, the package name, the class name, and the method name, and how much time is being spent in that component. So if you used the API object to identify there's a problem, and if you used maybe a service mesh to see, well, this is the component which is kind of slow, then you can use that to get the insight which part of the application is actually causing the problem and diagnose it that way. Now, the problem here is the amount of tools. So a stack that people might actually use often is having Grafana as a dashboard, Prometheus as like a component to aggregate and summarize all the information from the cluster, and OpenTelemetry as kind of an agent to feed into Prometheus. Another very popular combination is like the Elk stack. You can also do combinations of these and many different other things. So it will be really hard for me to go into each and every detail there. But there is help to get a bit of a kind of a separation and order in your mind. There's a website or a thing called the Open APM. This is something that is open source, but have been written by a few colleagues of mine, where they try to list all the various components and especially open source components in the APM space. And you can arrange them and try to fit them next to each other and see who is actually able to talk to whom, can import information from which component, and so on. I might show this in a second, but I just want to wrap these things up. So in this case, yeah, the agents are specific to programming languages. That means if you use programming languages where the agent doesn't support, it's not going to work. So you need to spend quite a bit of time of identifying, yeah, what am I using, what might be a good match, and where can I get the metrics from. But if you do that, then you get the best level of insights, application level metrics. The other downside of that is, of course, this needs to run really, really close to your application. So this is very often either a part of the application process, which needs to be modified, or sometimes I've also seen solution where it basically exists in the base layer of the container. So if you want to add and remove that, that will not only cause an application restart, that will also cause very often a rebuild of the application and the container. But in the end, you're going to get the root cause analysis only by using that. So I hope I was able to give you a bit of an overview of the various ways how to get insight to such a cluster. The way you do it is basically your own choice, but these are the various ways at least I am aware of. And so yeah, to summarize again, API server for like error identification, node or pod level for isolation, and then application container level for real root cause analysis. Now, I'm not finished yet. I still have, I think, 5 minutes, right? Okay, maybe not. So this is this open APM component I want to look into first. So for example, if we say, where's a popular one? You see, there's a lot of tools. So I can select Grafana now. And if I have selected Grafana, I see that here. And now I can select what are the possible inputs to Grafana. So I can take, what did we just see? Well, Loki, for example. So we have Loki as a database to feed into that. And then we can use FluentD to feed into Loki. So and everyone who has an own solution can contribute to that and place it here, so it's findable. And you can also model your APM landscape with that. So just as a quick teaser there. Now, what else did I want to show? So this is K9S. So you started right from the command line, so you enter just K9S, and then it's there, so it's pretty quick. So and you can quickly see this one tells me I have a critical memory level. This is probably not so good. Some of my pods are already evicted, so I should probably dig a little deeper in that cluster to see what is going wrong there. This is, and I hope you can kind of read that, the tooling of Lens, where you can see this gives a nice overview and summary of the workloads, configuration objects, network, and storage. So this definitely helps people, especially when learning Kubernetes, to group all the new things and get your mind wrapped around that. Let me think. Let me just check. Where is... So this is the Kiali console from the Istio service mesh. Let me quickly, if time allows, bring some traffic onto that application, because right now it's not going to monitor anything because there is no inbound traffic. This will actually hopefully change in a second once. Okay, now it's getting started. So it has to sort things out. And here you can see response time, throughput, traffic distribution, traffic rate, and so on. Of course, the coolest thing is that checkbox traffic animation, because now it starts to look really beautiful, and you see all the flows and what is happening there. What else did I bring up? I think I talked about the Hubble UI. Okay, so this has basically stopped. I have to restart that real quick. Where's my jump out here? Okay, so you run that by executing it from the shell. And then, yeah, so it jumps right in. And so you see, you don't need to instruct or inject anything into the various namespaces. It will all happen automatically. So you can see this is what the traffic flows in the Kube system namespace looks like. This is like how it would look like for my Spring Pet Clinic. So this helps you to get an easy understanding of what is going on there. So I think that's pretty much it. What else? What I did want to show for today. So yeah, I think it's 29 minutes. So then I can go back to this slide. Sorry, yeah, it's too many things. Yeah, which says thanks. So thank you very much for listening. I hope I was able to show you, some of you, a few new things. Maybe you didn't know all that already. Either way, if you want to talk more about that, feel free to come to our booth. This is our booth. This is my colleagues. So you see what they're doing. They're playing computer games all the time. So go there and stop them from doing those things and ask them like pretty difficult question about containers because that's what they're here for. And I also have another talk after the lunch break. So if this one is more on the application side of distributed systems. So if you're interested, feel free to pop by. And yeah, that's that.
Come to the center with me. Thank you, Matthias. It's Q&A time. You look very different on that picture.
Yeah, I always have to laugh when I see that picture. So thanks, marketing. Great job there. This is what I looked like prior to the COVID time, so it definitely had an impact on me. But it's me. You can believe that.
I'm pretty sure in that picture you just turned around on a chair, and we don't see it, but there's a white cat on your chest.
How do you know that?
I'm a people person.
Okay, good.
Questions. Is observability so multifaceted, or can developers just agree on a single tool chain or framework? White choice is good. Everybody seems reinventing the wheel. Yeah,
I mean, I can only confirm that second sentence. This is also the thing that gives me a bit of a hard time in like recommending certain technologies, because there are many, and there are many overlapping ones. But also this also leaves the space for people to develop new things and bring up new things and make it better. What I did not show today for a certain reason is commercial solutions for observability, because I don't want to do any pitch there. So I only showed open source things, and to give you a feeling of what can you expect from a certain level. I think there are commercial solutions which kind of at least promise an all-in-one solution and cover all those metrics. But that's something I didn't want to bring up because that would make it too biased. But yeah, I can understand that pain, and I see that too.
Yeah, why are there so many options? We have like follow-up questions. Do you know why?
Why? I mean, this is not only in the topic of observability. I think that Kubernetes kind of spawned an entire ecosystem of software that facilitates it in one or the other way. And yeah, we see that multi-option kind of thing in other assets too. So I don't know why, but I mean, it's like Kubernetes is open, has open APIs. You can easily write your application against that, and that kind of makes people do it. So that's probably why we have such a conference like this.
So the answer is because you can?
Yeah, because you can.
Can you give a rough estimation on the memory CPU overhead of Istio injection?
Well, not really. I mean, the proxy that's getting installed there is the Envoy proxy, and I think that's somewhere between 50 and 100 megabytes on memory, but I'm not entirely sure. And the CPU, of course, it doesn't. If it idles, there is no CPU. So the CPU basically comes when there's traffic on the application. But I don't have any figures on that. Sorry.
Okay. What tool would you propose for multi-cluster observation?
What tool would I propose for multi-cluster observation? So, I mean, all the tools that I've showed now can switch the cluster context quickly, and so they would all work for that. If you have like clusters being connected across each other with like service mesh functionality, then you should probably use the service mesh observability tools to do that. I hope that kind of answers the question. But in general, all of those tools, you can easily switch the context and just like drill through the information there.
Okay, we have 2 questions left. We will do them quickly before we go into the break.
Okay.
We cannot make the third one because we're running out of time. How's the implementation of a service mesh practical when it adds 500 ms of latency, and UX experts recommend on application to react in less than 100 milliseconds?
Yeah, I mean, service mesh is a kind of a difficult topic, and I see that also in my companies. There are people that really like the functionality of it. The other people really hate it because of the complexity and the overhead that it adds. And I mean, this is why I give that talk. I mean, I want to show what you can actually do with it, and I'm going to show more in my other talk what you can do with it in context of distributed applications. But you should always ask yourself: is that something that I really need? Am I willing to pay the price for that information that I'm going to get, or should I rather not use it and use something else and live with that and not causing this overhead? I mean, I can fully understand that kind of reserved perspective towards service meshes. And then maybe with eBPF, this problem can be solved, as you don't get this overhead once you inject the proxies on the node level and not on in the pods.
Okay, last question. How do you decide the amount of CPO memory to be assigned for proxies running at pod level?
How do I decide? I don't decide that. I don't understand the question, I think. But well, maybe you can come down to me real quick and we can
ask
talk
it
about
afterwards.
Yeah.
Okay,
yeah.
We also have a card deck for you.
Oh, that's cool.
That's cool, right? I think so. Thank you so much, Matthias.
All right, thank you.